Hello again. Fancy meeting you here. So when this video pops up, video feed pops up, I hope that you were able to watch the AP flicks about the hormone action. It went into a little bit more detail than I did, but it was a very good animation. So very beneficial. If you have not seen this, go back and check it out. So moving right along, talk about releasing of hormones, and mainly in this section, the three types of stimuli that promote the release of a hormone by an endocrine gland. I got to tell you, this is weird sitting here in my office talking to myself, and the dogs are looking at me like, "Are you talking to us?" No, I'm talking to some people that aren't here. They think I'm crazy. All right, so hopefully the video's on by now. The blood levels of the hormones are controlled by negative feedback systems. That's not unusual. We see negative feedback when we're talking about homeostasis all the time. We'll see a couple of examples of negative feedback later on as we go through each individual endocrine organ. So what we want is we want the level of hormone to be, once again, just like Goldilocks. You know about Goldilocks, right? You know the story of Goldilocks? What did Goldilocks do? Yeah, Goldilocks committed a felony, breaking and entering. She broke into the bears' cabin and ate their food and slept in their bed. The first bowl of porridge was too hot. The second bowl of porridge was too cold. The middle bowl of porridge was just right. And what is porridge anyway? Porridge is kind of like oatmeal. But anyway, the homeostasis is the same concept. Too much is bad, too little is bad, but just right, that's so good. So negative feedback helps us keep that internal balance and helps us keep endocrine levels, among other things, at a level that's just right. So the hormone release is triggered by primarily stimulation of the endocrine glands, of which there are three types. And that can be modified or modulated by the nervous system. So the nervous system can kind of add a little bit of oomph, a little urgency to a message if need be. So here are the three types of stimuli: humoral, neural, and hormonal. And just a brief overview here. Humoral refers to body fluids, primarily blood plasma levels. But remember, the term humoral refers to body fluids in general. Neural is just what it sounds like. The nervous system innervates a gland, and when the time comes, the nervous system sends an action potential to that gland and says, "Hey, do your thing." And hormonal stimuli, that's where a gland receives a stimulus in the form of a hormone from another gland, where one gland controls the release of another gland. That happens a bunch, but the main area where we're going to focus on that is going to be the pituitary gland commanding the thyroid gland. So changing blood levels of all these things that are under all these parameters that are under the influence of the endocrine system cause the endocrine glands to either make more or less of their product. Here's an example dealing with blood calcium. A&P I, you learned how important blood calcium was in muscle contraction and the propagation of action potentials. So if blood calcium levels start going down, then that starts to be bad. We don't want it to go too low. The parathyroid glands secrete a hormone called PTH. Well, the hormone's called parathyroid hormone, abbreviated PTH. Very convenient, parathyroid hormone. And that's going to magically cause blood calcium levels to come back up. No, it's not going to be magic. I'll describe that mechanism to you when we get to the parathyroid glands. actually quite fascinating. Anyway, so the increased levels of parathyroid hormone cause calcium concentrations to come back up, and then the parathyroid hormone taps the brakes on release of PTH. So there's one example of balance. So here we have humoral stimulus. So in this example, what we have here, there we go. Blood comes in. This would be the thyroid gland. This would be, in particular, a look from the posterior side of the thyroid. What would go right here in this notch would be the trachea. And here we have the superior thyroid artery coming in. We see the parathyroids, usually 4. Talk about what that means later, usually. And the thyroid thyroid glands. Sorry, here is the thyroid gland. We're talking about the parathyroids over here. They monitor the blood calcium levels, just like in the preceding example. If blood calcium levels are low, the parathyroid glands are monitoring that. Blood calcium levels get low, the parathyroids secrete their hormone. They go out and activate their target cells, which causes blood calcium levels to come back up. So in this instance, and we'll talk about the specifics of this later, but in this instance, it's an example of the gland, the parathyroid gland, monitoring a body fluid, in this case the blood plasma, for a particular parameter, which is blood calcium level. Example of humoral. Neural stimuli. That's where the nerve fibers or cells directly synapse with cells in an endocrine gland and cause the endocrine gland to release its product upon that stimulation. An example of the sympathetic nervous system, the one that gets you jacked up for fight or flight. They stimulate, they run and stimulate the adrenal medulla to secrete epinephrine and norepinephrine. Here's the picture. So here's the central nervous system, the spinal cord. We get a spinal nerve come out and going to synapse with the adrenal medulla. Now let's take a second here and see what that word means, medulla. One of the basic schemes or themes we're going to see in several organs. We're going to see this with the adrenal gland here, the kidney, the lymph nodes, a couple other structures where you have a capsule around the outside as a protective layer, acting as protection. Then the next layer in is called the cortex. The brain also follows this naming scheme. And then the innermost layer is the medulla. So in this instance, the medulla of the adrenal gland is the innermost layer. And whenever we need something, like maybe you broke into a bear's house and you're eating their porridge and they come home, and rather than fight a bear, you're going to run. Well, the nervous system will send out a message to secrete, cause the adrenal gland to release epinephrine and norepinephrine, together called adrenaline, and then you run for your life. And then that lasts a little while, doesn't it? Not forever, but a little while. Hormonal stimuli. That's where one gland sends a message to another gland that says, hey, release your product. So there's a pathway involving the hypothalamus, hypothalamic, pituitary, that the hypothalamus causes pituitary to release a hormone that then has its target somewhere else in the body, a different endocrine gland in the body. And let's find a picture here. All right, so in this picture, we have the hypothalamus up here. We have the pituitary, and specifically, we're going to talk about the anterior pituitary. By now, you probably realize that the pituitary gland is really two glands in one, where the anterior pituitary is of epithelial type tissue, and the posterior pituitary is neural type tissue. and we'll talk about those individually as well, where the hypothalamus releases it's releasing hormones, and then the anterior pituitary releases its hormone, where, for instance, thyroid stimulating hormone, TSH, is released by the anterior pituitary and it floats everywhere throughout the body, but its target cells are only in the thyroid gland. And so thyroid stimulating hormone doesn't have any effects anywhere else other than just the thyroid gland. A word for this, these hormones that are released by the pituitary gland are called tropic hormones. Tropic, that word will come up here in a little while. I'll explain that more a little bit later. But some of the examples of the pituitary gland controlling the thyroid, some of the cells in the adrenal cortex, and the gonads, the testes, and indeed even the ovaries. So as I mentioned a little bit earlier, the nervous system can make some adjustments to these hormone levels in case of need. So under severe stress, the sympathetic nervous system can override insulin. Insulin's effect is generally to lower blood sugar levels, blood glucose levels, a normal response to eating a meal. And instead of sequestering that blood glucose, it leaves it in the blood available for the fight or flight, like running away from a bear that's mad that you ate its lunch. All right, I'm going to see what we've been going for. Let's stop this one right here, and I'll pick back up in just a minute.